Hello, welcome everyone. Today we have a special guest with us. We have Dan, and Dan is going to be walking us through an introduction to AI. What is AI and why you need it in your game? So join us as he answers those questions and shows you how powerful implementing AI is in your game. And so I'm just going to hand it over to you.
All right. Yeah, so I'm Dan Violet Sagmiller. I'll do a brief intro on myself in just a minute. But uh, just the basic idea of this is the focus of it is to make AI easy to understand and design. And there's a lot of different ways that you can look at artificial intelligence. I mean, artificial intelligence has become a big thing recently. So much so that tons and tons of businesses and data scientists are taking a look at this and making all these learning AIs that are doing all these really incredible things. But game artificial intelligence is a whole different genre. What it actually takes to make your program smart so it can do things that make it appear intelligent, like they're playing potentially a real player versus another AI player, those are actually a lot easier than you might think. Basically, when I first started out in game development, the idea of artificial intelligence was really scary. It was this idea where is this big blank box, and it's like, what do we do? How do we get this to work? Until someone finally explained to me one of the most simplest truths of it, and then all of a sudden, all the AIs, or most all the AIs in games, just started to make sense. And that's what I'm hoping to share with you today as well. All right. So, a little bit about who I am. I'm Dan Sagmiller, this guy. I think the door's shut, so I probably won't have a cat on my shoulder, but maybe. I've done all sorts of stuff. I've written a book on AI in Unity. I've been published in magazines. I have a course out, which I think is going to be retiring soon because it was from Unity 5. For creating a real-time strategy game in Unity. And then I've done a whole bunch of other things. I've got various projects, different things that I've worked on. It's been a lot of fun. So I'm hoping that during this time, I'll be able to answer your questions on AI, but then also towards game development in general. Any types of questions that you might have along the way, just feel free to send them in the comments, and I'll try to respond. I may not notice them right away, but I'll try to. Okay, so let's move on. This is broken into 3 parts. And actually, let me check that. Yeah, 3 parts, and there's technically going to be a 4th if we have time. Okay, so first one I'm going to do for AI is a chase AI, to make one unit or ship or something else follow another one. The next one I'm going to teach is pathfinding. Like, I'm going to actually explain the code and how this stuff works. I won't go exact code. I'm not going to write out everything here. It's all in a presentation. But by the end of it, you should be able to understand how to do these. And then I'm going to teach you how to write your own chess AI. I chose chess because that seems like one of the really scary ones. Like, wait, how on earth would I create a chess AI? And in truth, it's really, really easy. All right. So first off, best description of AI ever. To me, anyway. If you've ever seen Space Ghost, there was an episode in there where Space Ghost is starting to mess around with the machine, and Moltar says, "Do you even know how to use that?" And Space Ghost says, "Moltar, I have a giant brain, able to reduce any complex machine into a simple yes or no answer." And that's really all that AI is in games. There's other stuff going on there, but think of it this way: when you start breaking apart an AI, should my spaceship go to the left? Should my spaceship go to the right? Those are just yes and no questions. So if I ask, should I go to the left? And whatever I'm doing to figure out whether or not I should go to the left says yes or no or true or false, then it will go that way. If it says no, then let's go on to the next question. Should it go right? Should it go straight? Should it stop? And we just kind of go through a list of whatever options we have. Now let's do a couple of kinds of AI here. I chose these ones on purpose because they cover different grounds. So what is AI? Cause and effect. Something needs to happen. Something seems to be natural. Something we have a cause and effect. Something gets triggered but what? Now that's part of what you program in your game, but it's a lot like dominoes. So a chase AI. This is the most basic chase AI, and you may have already written code just like it. If the enemy's X location, or if the enemy going left and right on the screen is less distance from the left side, or however the X's are set up, or the orientation is set up, than the player, then make the enemy start going the opposite direction or go towards the player. Basically, if enemy X is less than player X, then increase the enemy X. The enemy is now starting to head towards the player. And you do the exact same thing for Y. So if you have X coordinate and Y coordinate, so X going across the screen this way, Y going across the screen this way, and you've got these little enemies that are walking around, you get the arrow, etc., and your player is over here. All right, so you got the player over there, and these units are deciding to head towards it. That's all that it is. It's deciding, it's done one simple decision. Should I go that direction? Now that seems really straightforward and obvious. So let's go on to some other ones that are a little tougher. Well, actually, let's take a look at this one first. If enemy state, chase AI, this is another thing. There's a thing called state that we often add. So one artificial intelligence might just be deciding, should I do this one thing? And that's absolutely all it does. But then there's a whole nother layer of AI where it's starting to look at what was I doing? So for instance, if I'm close enough to a player, then I can attack the player. So we're taking a look at things like if enemy state is currently searching for the player. So we say something, in we decide, this could be a Boolean. It could be if enemy dot is chasing or is searching. If it's searching for a player right now, and it does a check to see what's the distance between myself and the player, and it says that that distance is less than the spotting distance. So in this one, distance is less than spotting distance. Let's say whatever function we have, and lots of game systems have functions for this, where you just say, give me the distance between these 2 points, and it tells you. Most game engines are really easy. Otherwise, it's Pythagorean theorem. Something covered in geometry. It's pretty basic, or they cover very early on. Anyway, but you get the distance between 2 players on the screen. And then if we find out that we are close enough to a target, then we're going to say, hey, set the target to the player, to this current thing. So you can see I kind of set this up where we have these different outlines on the sides under these different monsters. So this bluish one, which is a little hard to tell. It's the blue and green look almost the same. Anyway, this first one, closest one to the target on the side, is blue. So its blue sphere is touching down here at the bottom. Let's get rid of some of this stuff. So he's close enough that he can see this right now. That it's close enough in a distance to this player or to this enemy that they can see the target. So you can see their attention is also set to the player, or to, in this case, the target. The other 2 units are far enough away they don't see it. But that's basically the idea. We're saying all 3 enemies are in a state right now saying that they're searching. So every frame they do another check. If you're using Unity, you're doing updates. I'm not sure what other engines you might be using in there, but most of the systems have the update or every single frame of the game. But it does another check to see its distance. So this one's going to start heading towards the player. That's where it starts using this one to actually make the enemy move towards it. And there's a lot of other things that you can start applying to make it more interesting. All right. So anyway, once it gets there, we set the target, and now it's going to be enemy state equals enemy state dot attacking or chasing. It starts the chase. And then once it's close enough distance, again, closer than spotting distance, we might have something in there for attack distance. And if the enemy's distance is less than the attack distance, then it will start attacking. It will enter the attacking phase, and then that update will tell it, oh, I'm attacking now, so I'm going to do a little animation that says attack towards the player, and every 3 frames or every 10 frames or something, I'm going to deal 0.5 damage or something. All right. Now, the chase AI runs into a lot of problems. For instance, is it blocked? Remember, all that the chase AI can do is say, there is my target. I'm going to head straight towards it. If there's something in its way, it's just going to keep walking into this wall. So it's got this little animation just walking back and forth into this wall over and over and over again. You may have even seen this in a video game. If you catch an enemy right at the edge of a wall, then sometimes they'll just keep walking into that wall trying to get to you. Now, most of your modern games, your first-person shooters that are out today, the AAA games, you'll pretty much never see that because they program much better AI into it. And so, how do they deal with this problem? That gets us into pathfinding. So, in this case, we have a target way up here. And then the enemy is going to be traveling, and they need to effectively follow this path to get to that target. So I'm going to show you A star. A star is a really simple way of looking at pathfinding. Now, it's not perfect. I'm going to show you one of the faults. In fact, this takes advantage of one of the faults with search AIs or with pathfinding AIs, and there are better ways to do it, but it still will work. That's one of the key things I want to emphasize. This will work. Okay, so we want this. When we take a look at it, we know that to get up there, we just glance at it. It's like, oh, well, go around to the stairs. Once you get to the stairs, go up them, come over to here, and then head straight over towards the target. That's really obvious. That's straightforward. We know that. We can just glance at it. Our brains are equipped for this in 3D processing, spatial processing, really, really well. Oop, wrong one. Does there go to the other one? Yes, it did. Okay, so I switched from a perspective view to a top-down view. So here again, we have the target, we have our enemy heading towards the target, and that's the path we would expect them to take. Now, they could also go around this way and take that way, but that's kind of ridiculous. We would look at that and go, why on earth would we do that? That makes no sense. There's a really short way to do it right over here. AIs are not necessarily that smart. Some AIs are kind of dumb, and there's a lot of value to that we'll get into. Okay, so A star is really about finding a path from one spot to another. And in A star, we're assuming there is a grid. So we have, this one might be 1, 1, x of 1, y of 1. This one might be 2, 1, 3, 1, etc. for all these little points going throughout this. This one over here would be 2, 3. So this one would be 3, 1. Oh, sorry, other way. 1, 3, and this one over here would be 3, 3. That's its position in this space. Well, actually, I'm going by these cubes or the squares being this space, not the little points on the grid. Anyway, so we've got these points, and we need to get our player from here around to here. So what do? We start by taking a look at the most immediate spaces next to our player. These ones. All the ones that are adjacent to it. And we put those in a list called adjacent. So a list in programming is like an array, just in case you're not at that point in encoding yet. But a list is like an array, except you can add items to it, and you don't have to deal with resizing the array. You can keep adding and removing items dynamically. So they are very nice to use when you have something where you have to keep changing what's in a list or not. All right, so we take a look at what are the immediate squares. Now, how did we figure out what those squares were? We say, well, our player is at 10, 3, or something like that. Maybe that's accurate, I don't know. Oh, I did that. Be the other way. Whatever, this doesn't really matter, but oops. Okay, not what I intended. Can I go back? I am now having trouble with this. I can't get it to go back. Let's try this. There we go. I got my little controls up now. Yay, I found a zoom function that I did not mean to find. Mouse right over here. There. Okay. Sorry about that. So anyway, 3, 10, this particular coordinate right there. That's where we are. We are right here. And then we're saying add 1 to the left. So we're going to say 4, 10. We're going to say 2, 10. We're also going to say, let's see, 3, 11 and 3, 9. And we start to just get all these squares around it. We're just adding 1 and subtracting 1. And we just get those 8 spaces surrounding it. Now, the first thing that we do is we ask, is this an actual space that we can use? If it's not, because some spaces like this is a wall, we can't use that. The player can't walk there. We would decide, can the player walk here? And if they can, we add them to adjacent. So we're going to start growing this adjacent list, which will be signified with the purple squares. Anyway, let's go on. There we go. Okay, and you can see I've now added something else. This is a checked space, the one with the green line. We say what's out of all the adjacent spaces. Like once we figure out our adjacent space around us, like what are the new spaces, we add them to a list and we take a look at that list and we say, what is the closest item now? So what is the closest item now? And that from that initial square, that was going to be this spot right here. So it says, oh, well, I'm going to go to this spot, grab the surrounding stuff. Let's erase. Grab the adjacent tiles to there. And we already know that some of them have been added, so we actually don't take a look at these first ones. We say if it's already in the adjacent list or it's already in the checked list, then ignore it. Don't try to pull it into the list again. But we see that I have these little black spaces, these ones. This is a wall. We cannot use that space. So what would the next most likely spot be? Well, it's going to be right here, because that's the next closest spot to our target up here. Now, it's not looking at this from a distance standpoint of what it would actually take to get there. It has no idea. That's what we're trying to teach the computer to do. Anyway, so we've got this point here, and it knows that this one is closer than this spot. So let's go ahead and move next. And we can see it grabbed this spot. So now that it's grabbed this spot, it's going to continue that and most likely grab this one. Let's just continue, and we can continue and continue. And you can see this goes on for a while. But look at this. All of these spaces so far, it's gotten all the way over to here, like going all the way around to this side. And it still hasn't gone to this one because this spot right here is closer than this spot right here. So every time it's looking at this, it's still going back this way. It's effectively doing a spiral around the other direction. So let's take a look, and you can see it shows to go this way. It's continuing and gets over to here. And now it's a little questionable which one is closer, but not too questionable because right there is the next closest space. So it finds its path. It's got a path to get out there. Now, this is not a clean path yet. When you look at this, yeah, okay, this spot over here kind of makes sense. Okay, yeah, I can just follow this. That's good. That's good. Okay, and then, oh, my player's just going to go like this. The character's going to cover all these little spots until they're back to here, or vice versa. And that makes no sense. So this is where the A star does the exact same thing again, but with a smaller list of data. So let's move on. Whoa, I guess it thinks I zoomed. How do I zoom out? There. Okay. Can I go forward? I have no idea what it's doing. No? Oh, this All right, I think this is actually some of my software that's being used to connect that's messing things up. Small hack. Oh yeah, and so what's going on right now is I'm actually running this on a Surface so I can have my pen, and then everything's being streamed in live to my desktop. And usually this works really, really well. So let's hit escape. Once my keyboard attaches, there we go. Okay, maybe this will work now. Okay, yes. Okay, cool. So now the first thing that we did is we removed all the spaces that were not in the cleaned list. Remember, all these little ones over here were purple. In fact, I can just show it. See the purple ones? And then now you don't see the purple ones. All right, so it needs to start finding its way back. We do the exact same thing, but we start at the end and go to the beginning now. So let's take a look at that. We start following this path and we say, okay, well, what's the next closest one? Okay, it's over here. And at this point, we have no choice. We have no other choice but to go heading away from our target right now. But that's kind of the point. It's finding a way around the obstacles. Okay, so it's continuing, and eventually it found a path. Once it got over to here, it's just choosing what's the next closest one. That one, then this one, then this one, then this one, etc., until it gets right back to the player. And then we get rid of everything else. Now we've got a single path for it to follow, and it's clean. It's not the most efficient way. You can see we're taking this wide spiral, and the spiral really is the weakness of this pathfinding. There's ways around it. You can learn all sorts of different tricks with A star. I'll teach you a couple before we move on. But so what if we were to do this backwards? What if we said, in fact, I do this a lot of times where I say start at the destination and go backwards. Well, let's follow it. Okay, so it starts finding this. What's the closest one to our target? Starting from here, going to here. Well, it gets to this point. Everything is following, and it gets to here. And now, look at that. When we started at the end, it went all the way to the beginning over here, and it was really efficient. In fact, we could pretty much just use this path by itself, and we're good. But that's not what we're going to do. There's a reason that doesn't work. We can still use this, but it's not going to be efficient like this all the time. So it finds the path. It's got the path. When it goes backwards, it even cuts out this little one right there. So we end up with one list. Now these are the two paths we had. One, we started here and went towards that player, or towards the target, and then here we headed towards the target. Now, what happens if we switch their positions? So we say that our enemy is now up here and our target is down here. Well, then we're going to run into the same issue where we'll get the spiral. So the thing is that depending on the layout of your actual environment, they will choose sometimes some crazy paths, but they'll find it. Now, if the whole thing is blocked off, like we have a wall here and we have a wall here, and there's a closed door that you don't have a gate key to or something in the game, then it will return finding that it was unable to make a connection. Basically, the blockers will stop it. You'll go through every possible way through the level, and you won't find it. Anyway, did this again. Stop doing that. There we go. Escape. Woo. Okay, I'm getting the hang of it. All right. So anyway, you do this stuff where you're taking a look at what is the most adjacent space, and then what is the space that is, what spaces have you checked? And you just start refining that list down every step of the way. So, and if you want to, just look up A star online. There's a lot of tutorials. Some are easy, some are not. There's code samples. Everything is out there. And most game engines also have things for pathfinding anyway, but there's a reason why I tend to like A star. And I'm going to show you some of the advantages you can take while you're using it over some of the standard AIs that are built into, say, Unity. Unity is great. It's my preferred system, and I use it all over the place. But if I'm using a grid-based system for pathfinding, there's a couple of reasons I'm going to pick this. Okay, so let's take a look at this one. This is the worst possible case for A star to run into for pathfinding, for processing, for how many things it has to take a look at. Let's take a look at the time. We're at 4:25. That's cool. All right. So we're going to look at the spaces, and let's see what I do. Okay, yeah, I'm just drawing it. So we look at the spaces. It says, okay, all these ones, these are ones that we're going to look at. And then it says, okay, well, what's the next adjacent ones? Well, it's over here. Our path is like, well, how do we get to the player, etc. We keep going like this, and we get a straight shot to the player, but then there's this wall. We cannot cross this wall. So we keep going on, and we say, okay, well, what about this one? What about this one? No, same thing. We keep going down this list. And we keep getting all the spaces that are close to this as we keep expanding out to take a look at it. But everything over here, this wall blocks us over and over and over again. So we can't get through there. And eventually it looks at every single square in this spot. And then it says, okay, well, now I can go to here. And then my next space is here. Oh, and now I found it. It finds the path to actually get to the target. So this is one of the most inefficient methods to actually use. Now, one of the reasons that I point this out is because understanding how your artificial intelligence works is good for the designers of your game. Think about this kind of limitation when you are designing your level. You're setting up your spaces. What's going to be over here? What's going to be over here? How am I going to set up fences? What am I going to do in fence corners and stuff like that? And you can design your level to make sure you're actually allowing AIs to operate more efficiently. All right. Here's another one. This is bad. This is an Aero turret or something like that that attacks the enemy as it tries to get to the target. So if it goes in a straight line or just does the basic avoidance, it's going to be passing right next to this. So how are we going to affect that? Well, do you remember when I said that all we're doing is we're saying, how close is this square to my target? Well, this square is 1, 2, 3, 4, 5 away. Okay, that's great. Well, we've got this turret over here that can shoot at this distance. So what happens when my player, let's clean this up a little bit so I can show it a little easier. The turret can shoot at this distance. So we know that we don't want to get shot by it. We don't want to get hit by this turret. So player walks forward, or enemy walks forward and says, escape. Woo. All right. I still need that one. Got 2 keyboards on here. That should work. Okay. No. All right. So it says, okay, this one is 1, 2, 3, 4, 5. It is 5 away. And this one over here is 6 away. We'll just use this basically because it's 1, 2, 3, 4, 5, 6. And then it can get to it. So it's going to choose this path. And then the next most obvious space, when it goes around and says, okay, well, I can go to any of these spaces here. And it says, okay, well, I'm going to go to this one. This is the next one that I will likely want to, or I'm not there yet. I'm just taking a look. These are my adjacent spaces around it. This one, it says, is 7. This one, it says, is 6, which we can't use because the player's on it anyway. This one is 7 as well. This one is 6, etc. Now, it would stand to reason that this one would normally be 4. We say, how far is the distance? Okay, well, it's 4 away. 1, 2, 3, 4. And that would make sense. But what we can do is after we say how far is it away, we can say how dangerous is this spot? Is this spot in threat of being attacked? Okay, well, we're going to say if in attack range, if our distance to a thing that can attack us, I'm going to have to take a look at the software that I'm using and figure out how to use that part or why it keeps doing that. I just did it again. Can you take advantage of it at least? Not that I see how. All right. So anyway, if we are close enough to an attack, stop that. Can you just escape that? And I think I just, yep. Start this again. Does it keep where I am? No, it starts over at the beginning. Technical difficulties, yay. Halfway through. Okay, switching this over to a different mode. Go here. Skip ahead through that stuff, and we are right there. All right, and then let's go to slideshow, and from current slide. That was obviously not current slide. Whatever. Let's try this again. Go back. Eventually, I swear this will work. Okay. And what is this? From current slide. Okay, I saw it light up on the right one. And it switches back. I can't draw in this mode. Yeah. It's on, I've got the display screen. Wait, can I draw? No, I cannot. Draw. Back, let's try it again. Pen. Okay, I can sort of draw. All right, I will take it, I'll use it. I'll go with it. All right, so over here we've got the, if we're in attack range, let's see if I can do this, attack. If we're in attack range of something, then +2 to the distance. So now, instead of being 4 away, this one, can I erase these other ones? I cannot. All right. So now we are 6 away. I'm just going to do that. It says that we are now 6 away, etc. This one is 7 away. This one over here is 1, 2, 3, 4, 5, 6, 6 away. And this one over here is 5 away. So from here, it's going to choose, it has to look at these and it'll likely take a look at either this 6 or this 6 and go to one of those ones and pick them. Whether it picks the first one or the second one doesn't really matter. But anyway, we pick this, we say, okay, well, this is the closest one to our destination. So we will take a, we start following it and we get to 6, then to 4. And it also takes a look at this, trying to say, oh, well, this one might be closer. Again, it looks at this. This is 1, 2, 3. It's 3 spaces away, but it's in range, so it's technically 5 spaces away. Just by configuring the distance, by altering that distance check to say, how far am I from the destination? We've changed the map so it will naturally avoid dangerous spots. So now the AI will appear smarter. It's going to naturally evade these types of issues. All right. Now, what if we wanted to do the opposite? What if we wanted to get closer to a treasure chest that it's finding? Well, what we can say is this treasure chest might have a larger range. And if anything is close, the closer you are to it, it will do something. So if you're in this outer ring of distance, then you will get a +1 bonus, or sorry, -1 bonus, the opposite direction. -1 bonus. In this ring, you get a -2 bonus, and this one you get a -3 bonus. The point being is, how close am I to the enemy, to my target? Well, I'm going to try going this way. It's a straight line. I should just be heading straight over there. But I ended up in radius of this. So when it says what's closer, this one, or this one, they actually all come out equaling the right thing. So I don't know, 1, 2, 3, 4, 5. This one is 5 spaces away. This one is 1, 2, 3, 4, 5, 6. This one is 6. So it ends up going straight. Next, it has to choose between this block and this block. And this block over here. This one is 1, 2, 3, 4, 4 spaces away. This one is 1, 2, 3, 3 -1 because it's in that first ring. So we're actually in 2 spaces away, technically, the way it looks at it. And then over here, we're going to say we are, with this one, this is -2. This is 1, 2, 3, 4, -2. So that's still 2 as to which one we choose. And then this one over here would also be -1. Yeah, it's not working out. The math would have to change a little bit. So in this one, I'm going to keep it with -1, this one -3, this one -5. If I do that, then the numbers start to show up and make the distance actually work out better. And you might have to do that with different AIs. You take a look at the numbers and decide this one has a little bit more value. The closer it is, the more value it gets. But you can see that eventually what's going to happen is its path is going to curve in towards this treasure chest. And then it's going to make its way back out to the target. So then on the way back, we just take a look at, we skip all of the bonuses and the detractors, and we just say, well, what's the fastest way to get back? So when we take a look at it, its fastest way back, or it ends up taking a path something similar to this, and just has, let me erase most of this. We effectively go like this to get there, and then on this one, we're pretty much just heading straight towards the target. But then on the way back, when we do our backtracking, it's just going to look something. No, there. Goes to something like this. So our path is effectively going to be something pretty much like this. Our unit just decided to intelligently go pick something up first. So you can have a whole bunch of decisions based on this. You could have a farmer in Minecraft who decides that I'm nearby a farm. I'm nearby some stuff that I can plant or affect. And so it will make the choice to start heading towards those. And it might have an intention of getting to a specific destination first, but it can't. It sees tomatoes that are ripe and needs to take them. So it travels by it on the way and grabs them. All right. So let's move on. Chess. So in a very short period of time, I'm going to teach you chess AI. All right. So chess AI is, yeah. So chess is, for those of you who don't know how to play, there's just a few basic moves for each type of the pieces. This is a castle, or, oh, this is red. Can I change this color? Let's go color, ink color. Let's go with blue. That's a little better. Okay. Oh, let's go with black. That should work even better. Okay, yay, black. I'll go with that. So this is a rook, or a castle. It can move horizontally and vertically any number of spaces on the board. This is a bishop. It can do, oh, sorry, no, this is your king. It can move one space in any direction. This, get rid of all these things, yay. This right here is a knight, a horse, or a knight on horseback. And this one does something that no other piece does. It can pass other ones. So it makes an L shape. So it can go like this, an L shape like that, go away. It could go this way. It could go up this way. It can go this way, etc. It can do an L shape where it goes two in one direction and then one in another, or one in one direction and then two in another. You're allowed to use it any way that you want to that way. And then as long as you land on a piece, you take out the piece. So this knight can take out the white castle or the white king or the white castle. So we've got these two players right here, and that's effectively how the pieces work. And then if you are in check, like right now, since I can take out the king, that king is in check. And so this player has to make a decision that will get their king out of check. That could be attacking the piece that put it in check, and since it can't, then we have to move the king. So we just move the king out of range, which we could move them here. That's fine. We could pretty much just move them anywhere, and they're no longer in check. Now, the black pieces also have a queen. The queen can move like the king, but any number of spaces. So it can move like the castle, where it can go horizontally or vertically on the board, any number of spaces, but it can also go diagonally. So the diagonal has another, well, actually, I'll just leave it that. You can't cross over another piece with this. So if you have one of your pieces in the way, it's blocking, and it just won't be able to move past it. If you have another piece, like the castle or something, then you can attack the castle. You can attack the other piece, and you take it out. I effectively, let's just say, if I were to move my knight over to here, this white castle would be gone, and my knight would be in that spot. And then it's the white teams, it's the white pieces move at that point. Okay, so So chess has some really basic rules, like how the pieces move are pretty simple, but the combinations of how you can put your king in check are very complicated. So let's take a quick look at how do we actually put an AI on this to decide what is my next move. Well, let's take a look at this. You just have a few rules on this that say, one, is my king in check? Is my king in check? And you take a look at all the opponent's pieces and you say, can it attack me? Is this a reasonable move for it to attack me? And if it can, like right now, yeah, I can be attacked, or that can be attacked. I'm going to say minus 1,000 points to the current board. Minus 1,000 points to the value of this board. That's what I'm starting out with, a negative 1,000. And then I might take a look at, can I take out one of their pieces? Can I take out a pawn? And if I could take out a pawn, that would be negative, or that would be positive 20 points or something like that. And if I could take out a power piece, like a knight or a queen, or if I could take out a knight or a bishop, that might be plus 100 points. So I'm asking these questions. Can I do this? Can I do that? Well, no, I can't take out a pawn. I can't take out a power piece of my opponent's. And they look down to see what the rest of the stuff are. And basically, they come up with a value of the board. So in this case, for this simple set of rules, we'll just say that my current board, the current board as is worth negative 1,000 points. So then I take a look at what moves can I make. I list them out. I say, well, this king could move here, 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 or here, or there. It's 8 potential moves. This rook has more places. It can move to any of these spaces along the way. Same thing, it can move over here. So it's got a lot of things it can do. But since you can only make one move at a time in chess, you just take a look at, well, what one thing can I do? With that one thing that I can do, I say, okay, well, what's the value of the new board? All right, so my king is over here. What's this going to be worth now? Well, I am no longer in check. So my new piece is not starting out at 1,000. So negative 1,000. Let's get rid of that. Get rid of that one. We're going to say, can I take out a pawn? No, we can't take out a pawn. I'm not in check. Can I take out a power piece? If my king is here, I could take out the knight. I could take out the knight. That means this is plus 100. This board value is 100. Okay, that's a great board value. And if it basically goes around and just takes a look at each one of them and says, if I were to make the move here, what would be the value of my board? If I were to move here, what would be the value of my board, etc. It keeps moving around. Same thing, moving this one to all the potential spaces it can go. And it puts a value on the board. All your work is to figure out how much points to apply to these things. Now, there's a lot more things you can do with AI, and when you get to the learning stuff, you really get some interesting situations. All right, but anyway, we can see that if I put my king here, I go from a negative 1,000 point board to a positive 100 board. And let's say that none of the others work out quite as well. Well, obviously, I'm going to choose this particular setup. So my king moves over here. Now, here was one of the things. When I had Windows 3.1 on a 40 megahertz machine, I was playing Chess Master, where you can play against a Chess Master or a whole bunch of other types of AI styles. And it had this little thing where it would tell you how many evaluations of boards it did. And Chess Master, before it actually chose what it was going to do and made a move, had gone through over 3 million possibilities. And why is that? Because not only does it check each possible move that it did, but it also expands out and says, well, no matter what the value of this move is, let's take a look at all of the potential moves of my opponent, and then what possibilities I can do after that. So it starts taking a look at it and seeing what are these new opportunities. And every time it assigns a value to the board. Usually it's going to take a look at the best possibilities to say, well, what's my next move? What can I do really well here? So it takes a look at its possible moves and it says, okay, well, for this first move, it's going to be this space. And then so I'll just assume, let's take a look at where will it head from that. And if it ends up being in check again after that it can get into check very easily by the other player, then that suddenly starts to detract from its parent, this move. So it takes a look at it and says, okay, I'm here. Well, okay, if the queen, or let's see. No, can't do that. Can't do that. I don't have a good option. I thought I had one worked out before, but whatever. Let's just say it works into another situation where it finds out that if the queen moves over here, that it's going to be in check now. Now, that's also a point where it can take out the queen. But basically, when it's taking a look at this, it just says, okay, well, what is this potential value that I could take? And then it says, well, okay, if I'm taking this route where I go to this move, and the enemy's best move will most likely be this one, what is my next best move? Well, that's going to be this one after it does its evaluations of the most valuable moves on the board. Another thing that you might evaluate is how many power pieces do I have? How many knights do I have? How many rooks? How many bishops? How many pawns? How close is a pawn? There's another thing in chess where if the pawn gets all the way to the other side, it can become a power piece of any type, whether that's a queen, a knight, a castle, whatever. So you could also there's just tons of things. If you just take a look at the basic rule book of chess, which is surprisingly not as complicated as you would think, it's really well set out to just do XY differences to say, okay, well, I'm on a grid with XY, 8 by 8, 64 pieces or squares. And then I've got certain rules to say I can move this direction, I can move this way, and how much is it worth? And you come up with a value. Anyway, so that's how you develop your chess AI. And basically you say, well, which path is going to lead me to the highest value reward? And you do have to take a look like, well, what are all the options that the enemy can do if you're going to expand past that? And as you get farther into this, there's shortcuts. You can start realizing, well, what's more likely to happen, and I can avoid certain pieces. You can start taking a look at what's going to draw the player in. Like, I'm going to put my queen out there because their knight will likely take my queen or whatever. But then 2 more spaces down, I can have their king in check, and there's almost nothing they can do about it. Then that's great. That all of a sudden puts this horrible spot where I lose my queen into suddenly far more value. But that's part of the trick of AI. You just keep looking at these numbers. You turn whatever problem is into a number and decide, is it greater than or less than a particular decision value? And then you do that. Okay, so we've got about 12 minutes left. Yes, feel free to ask any questions. I am paying attention to this question board along the way. But this is the bonus part. So I'll start bringing up stuff on this, but otherwise ask questions, please. Okay, so complex AIs. So far, I've been on a fairly basic AI, like where we're moving in a particular direction, or we're doing a pathfinding, which is great. You can use that to solve mazes. What was it after pathfinding? Oh yeah, chess. Chess, which this is just a large number of scribbles after that. But now let's take a look at something a little bit more intelligent. Like we have 2 characters in a game, NPCs that might be walking around in Minecraft or in a first-person shooter. We have a first one, which is a guard, and this one is very, very simple. It has patrol. It has investigate. Investigate might be that there was a noise, a door shut. You knocked something over. There was an explosion. So if it's within range, that will trigger its investigate. It goes from patrol to investigate, where it tries to head towards the source of what interested it. And then there's a chase. Chase is triggered because it is in range of the player. And then attack is because now it is in attack range of the player. So first thing is that they might start chasing the player. Then once they get close enough, they will choose to start attacking. Now this is very basic. If the player escapes it, then the NPC will first go back to chase, and then they might go to investigate to go towards the last direction that they saw the player go. And then finally, if they can't find the player, they go return to patrol. That's fairly easy. But then we have a more complicated one, a random shopper. You're inside a mall. This is a background NPC, but you want them to look like they're doing intelligent things. So they have 2 basic AIs, 2 root level AIs. And those are find an interesting store and do an area activity. So if it finds an interesting store, it will head to that interesting store. It'll head to that point. And then it will do an area activity. So once it's in that store, that area, it says, what are the activities? And the store has a list or whatever. You create this when you're designing it. The store has a list of a player. These are baskets that the player can shop from. So the player will, the NPC will walk up to a random bin, and it can do things like find a random, go to a particular shelf using A star to find your way there. Check the shelf. So now in check the shelf has more things. They can pick up an item and look at it, and then they can choose to get it or not. And if they don't get it, they put it back. If they do get it, they put it in their little basket that they're carrying. And then it decides, should I find another shelf? Should I check a shelf? Should I check my wallet? Should I check out? Should I leave? These are all different things that it's deciding what it can do. So I'm going to call these thoughts. These are different thoughts that our NPC can have. And our NPC is basically a brain deciding which thought am I actually going to follow through. Now, you can be distracted from a thought. That's the idea of I'm patrolling, I get distracted, so I go investigate, chase, or attack. Things can trigger the change, or I can trigger it, and I'll get into that. So let's take a look at this. Breaking this down for the NPC Guard. Let's say that a behavior or a thought has an interest level, it has an activate and a deactivate function. So when we're going to say, what is our interest level? Okay, well, patrol is basically going to be half a point always. It's going to be half a point. It's always going to return that. It doesn't need to do any investigation or any check on the level. It just says, okay, if someone takes a look at this behavior and decides whether or not I should be running it, it's at 0.5, period. I just return 0.5 all the time. Next, my investigate. I check each one of the behaviors, each one of these thoughts. So patrol, the thought patrol, or the patrol thought is going to be worth 0.5. The investigate is going to be 0 or 0.75. So what we're going to say is investigate, when we say get interest level, that function might do something like, is there a sound? Is there something that just happened in the previous frame? Is there an explosion? Did something fall over? Was there a gunshot? Those types of things decide whether or not I suddenly have an interest. Have I gained an interest? And if I have, if something interesting has happened, then I'm going to return 0.75. I have an interest, and it's for, here's my map. It happened over here, somewhere in this area. There's a wall over here and a door. So, and my NPC is over here. So they're going to want to check out this area to see what's going on. All right. So the investigate just says, okay, there was something that happened recently in a list of, we just track if there's ever an explosion, ever something that gets knocked over and it's within range, we can do whatever code we want to decide how they get an interest to investigate. But anyway, then they say it's 0.75. Now that's drawing them to here. There is nothing for chase or attack yet. Their chase AI is basically, the chase thought is basically saying, okay, do I see a player? Am I in line of sight? And in Unity, you can do something like ray cast, where you cast a ray and see, does it go through any physical object, like any wall or box or shelf or something before it gets to my target? And if it does, then I can't see them. And that's a great way to decide whether or not you chase, whether or not you can see them at any distance. Otherwise, you can also put a distance check in there and say, well, that ray cast is limited to 5 meters. If the player is farther than 5 meters, then the enemy can see. Anyway, so if they get it, if they are within range, then all of a sudden it goes to chase. That AI is now choosing to throw things like run. It's heading, it has an exact heading towards the player. And it keeps going after the player until it can't see it anymore. Finally, it's got attack, where it's checking, can I attack? Can I attack? And that is a thought level where it's going to return 0 or 1. And so no matter what the value of the rest of these items, if the attack value goes to 1, which basically will say if we're close enough range for the weapon to work, like 1 meter away or something like that, then the attack starts. It goes into the attack animation. that's basically how we decide which one of these thoughts. It's which one has the highest priority. We go through each one of our potential thoughts and we say, get our interest level on this particular one. And each one of them will just do a small function check to see which one should I do. And you can add those, make them however complicated you want. So another thing might be, so you have a brain. I was talking about thoughts and brains, or in this way I called it brains and behaviors. There's things called behavior trees. So if you look it up, you'll find a behavior tree, and this is following the basic principle of this thing. But you have a list of behaviors inside of your brain, or a list of thoughts. I chose thoughts because I find it a little easier to think of it as thoughts. But we've got an active, let's see, time, we've got 4 minutes. I haven't had any questions yet, so I'm going to go on with this briefly. All right. So over here, well, yeah. So basically the brain, you say, well, what is the current active one? And most of the time that's going to be patrol. And then you've got a list of behaviors. So we're going to check for interest on each of those behaviors that we have in the list. And then it says, gets that value, and it says, oh, well, if this is a different one than our active behavior, then I'm going to deactivate the previous one and activate my new one. And now it decides to go off and do that stuff. And the other one, which was if it had child ones like this AI might actually have sub-thoughts. So once it goes to this sub-thought that's here, when it's done with it, it's not going to look at other ones inside it. It's going to go back to the check shelf. And then when this one's done, it's going to go back to do area activity until something else takes its interest. Anyway, so that's the basic idea of how these AIs work. One of the things, I'll add this one analogy that the creators of StarCraft 2, I can't remember the name of who said this, but they were on the AI development team for StarCraft 2. They said, do the simplest, easiest possible AI to begin with. Literally just say, put a list of things that the character can do and choose one at random. And then try it out. See what the game does. It might work great. It might look perfect. But as soon as you see it happening, you can decide when things looked poor, when it looked like, well, that was a dumb decision. Why on earth would it do that? And then you can decide, okay, well, how do I avoid that decision? You write code to say, well, under this circumstance, in this case, when the map is laid out this way, when I don't have a path to my target, then I'm going to choose this route. And you can start building up the complexity slowly. One other thing is the cheesier your graphics, like low poly, if you're using low poly graphics, like Minecraft characters, or you are using first-person shooters like Gears of War, something really super realistic. The more realistic you are, your environment is, the more realistic you expect the AI to be. And if the AI is, and then that becomes a bigger challenge. If you're using low poly like Minecraft, you can have almost any AI in there you want, as simple as it is, and people accept it. Anyway, so I'll leave that for that. Or I think I'm done now, unless anyone has questions.
Awesome. Well, if any questions are piling up, I just wanted to thank you, Dan, for coming over and giving us this amazing introduction to AI workshop. I'm sure it has helped so many other students. And if you attended, thank you so much for attending. Just to give you a heads up, in about 2 minutes, we're going to start with a using Procreate for drawing animation and assets workshop. So tune in for that if you're interested. And once again, thank you so much for coming, and thank you, Dan, for hosting tonight.
Awesome. Glad to be here.
Yeah. Looks like there are no questions. So I think we're going to call it. And once again, thank you so much, everyone. Hope you have a great evening.
Bye.